In this video, we will learn how to identify outcomes and event probability. In this case, we have the following statement. A coin is tossed 3 times. An outcome is represented by a string of the sort HTT, meaning the head on the first toss followed by 2 tails. The 8 outcomes are listed in the table below. Know that each outcome has the same probability. For each of the 3 events in a table, check the outcomes that are contained in the event, and then in the last column, enter the probability of the event. So, 3 events, let's look at them one at a time. First one, 2 or more tails. So you're looking at your sample space, which has 8 events, and you're looking for things that have 2 or more tails. HTH has only 1 tail. TAH only 1 tail, HTT 2 tails, so that's the one that I'm going to check. HHT is a no, TTT is a yes, at least 2 tails. Next one, TTH, yes, at least 2 tails. Next one, yes, and the last one is a no. So out of 8 outcomes, 4 meet this requirement. It means 4 out of 8. After your simplification, a half. So I'm going to write down 1/2 as my outcome of this first event. Event 2, more tails than heads. So anytime you see more tails than heads, you make a check mark. I would say the third event, HTT, the fifth event, TTT, the 6th and 7th, pretty much same check marks as in the first case, but as you can see, event is differently described to us. Still, probability will be 1/2. 4 out of 8 outcomes meet this requirement. Last one, a head on the first toss or the third toss or both. So if we see H in the first or third or both of those places, we put a check mark. So I would say first one is a yes, next one is a yes, because the last thing has a head in there. Next one is a yes, next one is a yes. The TTT has no heads at all, so it's a no. Next after that, which would be our 6th outcome, TTH is a yes, because there's a third toss with an H in there. And 7th one is a no, because H is not in the first or third place. And lastly, 8th one, yes, because we have H in the first or the third or both places. So in this case, we got 6 out of 8 outcomes meeting this requirement. When I simplify this by dividing a common factor of 2, I get 3/4 as my probability of this event.